Hello, I'm Abdullah Fayaz and welcome to our MediaSphere infrastructure demonstration. MediaSphere is a comprehensive social media platform for media enthusiasts supporting movies, TV series, books, anime, manga and games. Today, my teammates Rafiqul Islam Ryan and Shumon Hossain will join me to demonstrate our complete development pipeline, from integration to deployment.
Hi, I'm Rafiqul Islam Ryan. I'm here to demonstrate the integration of the layers of our project. MediaSphere follows a monolithic architecture with three main components. The front end, which is made with Next.js 15 and React 18, while using Clerk for authentication and Redux UI components. The backend, which is Spring Boot applications with Spring AI integration. And lastly, the database, made using PostgreSQL 16 and containerized with Docker. Let me give you a brief intro of the front end. In the front end, the framework we used was Next.js 15 with React 18. As you can see, the language was TypeScript. Styling, we used Tailwind CSS with Redux UI components. We used Clerk for authentication. React hooks and context were used for state management, and we used Jest for testing. And there was Framer Motion available for animations. For the backend, we used Spring Boot 3.5 framework with Java, PostgreSQL and Hibernate for database, JWT tokens for security, JUnit 5 for testing. We used Maven as a build tool. And for the database, primarily, we used PostgreSQL to make a relational database with normalized schema supporting users, clubs, threads, media, events, and notifications, and many other attributes. We implemented proper foreign key relationships, constraints, and indexing for optimal performance. We also implemented automated migrations, health monitoring, and backup systems with Docker containerizations. Now let me demonstrate the integration process using a simple example, a user creating a thread. Let us walk through the individual events that happen in this case. When the user clicks on new thread in the front end, and the user then fills the form, and data gets prepared for the backend. Let me go there. Frontend calls API service, which is handled by auth service. This in turn sends an HTTPS post request using the fetch method via the proper API endpoint. This request is sent to backend via JWT token. After the backend receives the request in appropriate controller class handling the endpoint, in this case the club controller. The club controller validates and processes the request header, and after that it performs authentication check plus input validation. Then the data is sent to corresponding service class, and in this case this was club services. In the club services, it handles the business logic like performing calculations and processing on the data it receives from the database via a repository object. In the thread repository, the repository class is one which performs database operations by interacting with the database directly. There's also model classes, which maps the table attributes of each table into variables, which enables Spring Boot to perform automated queries. After data is sent to database, it performs CRUD operations like storing the record, like data. It may run queries, insert into threads table. Then the backend sends the response to frontend using the same route. Then the frontend breaks down the response JSON, and utilizing the data, it updates the UI. The user sees this in form of toast notification and a UI refresh. We get all this in the frontend. As you can see, if I create a new thread for demonstration, thread title BC, maybe thread content maybe DEF for demonstration purposes, and just in this single, for a split second, the operation that took place in the background, we have seen it all. By seeing the data flow from the front end to the back end of the database and vice versa, we can see a proper implementation of integration mechanism of our project.
Hi, I am Shumon Hossain, and I will be walking you through the testing mechanism. We have implemented testing in both the front end and back end layers of our project of testing. Our MediaSphere backend implements comprehensive unit testing using the Unit 5 and Mockito for the service layer. We have implemented backend test inside config and service folder, which are nested inside the MediaSphere backend folder. Let me demonstrate the testing mechanism by running it. Here it can be seen that all these tests are successful. Now for the front end part. Our MediaSphere frontend implements comprehensive components testing using Jest and React testing library with TypeScript support. Now let me show our frontend test by running them. Just like the backend test, you can see that the front-end tests are also successful. That it for the testing mechanism, my teammate will now demonstrate the building and deployment part.
Now I'm gonna walk you through the build and deployment phases of our project. For building our project, we use Docker. The first stage of Dockerization is building Docker images, for which we created Docker files. We containerized the front-end, back-end, and database layers separately. So we made individual Docker files for each of these layers. This is the Docker file we used to build the image of the backend. Here we listed all the necessary dependencies and commands to containerize our Spring Boot backend. Next is the Docker file for the database. We also listed dependencies and needed commands here, but in addition to that, we performed this one task. We put the entire schema separately in the init folder. This schema generating file that we put separately in the init folder, this Docker file copies it to the database entry point via this line and executes it. So we get our entire updated local schema along with the table data in our database Docker image. Next comes the front end. In the front end, we faced an issue when deploying it to the VM. So we created two separate Docker files to handle this situation. The first Docker file that I'm showing is the local Docker file, which handles Dockerization in local environments like running on someone's PC. Here, we set the environment variables, the next public API base URL and next public app URL to localhost sites respectively. Then comes another Docker file, which is the dockerfile.production for the front end. Here we specify it to the VM's IP address. Now, using the Docker files, we run Docker build and get the Docker images. After that, we push the Docker images to Docker Hub. Then comes the deployment part. In the deployment part, at first, we SSH into the VM by using this command. Then here you can see that we logged into our VM. Now by running the command docker ps, we see all the running containers. Here you can see that there are 3 running containers, the front end, the back end and the DB. If we go inside the MediaSphere folder here, we can see that there's a production YML file. Now we use the Docker Compose production YML file to pull the images from the Docker Hub and run them here. So this Docker Compose production YML file, this one handles the pulling of the images from the Docker Hub and running them inside the virtual machine. So it performs 3 services at once: the pulling and running of the database, the backend and the front end. Now you can see that in case of the front end, it pulls the image from the repository that we mentioned here. In case of the backend, it pulls the image from the repository that we mentioned in this line, and for the Postgres one, it pulls the image from this one. Here in this YML file, we need to specify the environment variables, which I did here for the database, here for the backend, and for the front end we did this here. And in this environment variables, we need to specify the keys used by our APIs, like the Clark keys and the next public API URLs, etc. Then comes the deployment part. Now, in the VM, as we are running the containers, we can see from the docker ps command that the front end is running at 3000 port, the backend is running at 8080 port, and the database is running at 5432. So if I show you that these are running, to show you this, I need to go into the front end, the backend, and the DB. Now here in the browser, as you can see here, the address is that of the VM, which proves that we have deployed our front end to the VM. For the backend part, we can see in the front end that there are data of the users in here. Like we are logged into our profile here, and it shows that the user is in 10 clubs, 5 discussions, 4 events. So it proves that it is fetching data from the backend. And now for the GitHub Actions and CI/CD part. Here in our repository, we created 2 files which are in the .github folder, the build.yml and the .deploy.yml. This build.yml is a GitHub Actions defining file which does these things. It does build and push. So when we push to our GitHub repo, this GitHub Actions file, build.yml and deploy.yml, they run automatically. So what they do is, for the build.yml file, it builds our Docker images locally by using the docker build command and pushes them to our Docker Hub. It does this same task for the backend, database, and the front end. And after it performs this task, it gives a success notification. For the deploy.yml, it does that thing like the build and push Docker images, and on top of it, it also does some extra things like deploy to our Azure VM. Now for the deployment, we need to perform an SSH connection first. So we do the SSH connection using these variables. Now these variables here are declared in the GitHub secrets. After using the SSH command to secure a connection, we need to pass on all the values of the environment variables that we used here. After that, we need to do these commands, which are pulling the latest images from the Docker Hub, then starting the services and showing the running containers. If all these tasks are successful, it shows a status notification which echoes deployment successful. And we can see here in this link. If we go to our repository and then to the Actions tab, we can see that when we push something, these 2 tasks, these run automatically and show a notification if they're successful or not. And here you can see that these 2 are successful, which means that by pushing anything to our GitHub repo, we have successfully deployed our entire front-end, back-end, and database containers to the VM. That's it.